All right, you should now be familiar with lines of best fit vocabulary. Now we're going to actually dig into writing equations of lines of best fit. So at the end of this video, you'll be able to write an equation for a line of best fit for a set of data points. All right, so what we're going to be looking at is just a scatter plot that's already been drawn for us. And then we're going to try to answer some information about it and then see if we can draw a line of best fit. Okay, so if you look at scatter plot 1, you'll notice on the x-axis it is labeled cricket chirps per second, and on the y-axis it is labeled the temperature. So some maybe scientist or biologist or something went out and actually was out in the wild and counted how many times they heard a cricket chirp and then recorded the temperature at that time. So you'll notice there are several different data points. I'm just going to refer to a few of them. So you'll notice a cricket chirped almost 18 and a half times, and the temperature outside was about 85-ish. This one would represent a cricket chirped 16 times per second, and the temperature was 71. And then another cricket chirped also 16 times, and the temperature wherever this data point was taken was about 80 degrees. Okay, so that's what all of those. So these are all different observations, probably from different places where the scientist was studying. So what we would like to do is, first of all, notice, is the correlation positive or negative? Well, you'll notice as the number of cricket chirps goes up, the temperature seems to go up. We're seeing this upward pattern. So I would say this has a positive correlation. The next one we're going to look is the correlation weak, strong, or is there no correlation? I would say that most of these data points, somebody already drew a line of best fit for us. The data points are pretty close to the line. We don't have any like down here or way up. We don't have any way far away from the line. So I'd say that it's a pretty strong correlation. All right, so the next thing that it says is to write an equation for the line of best fit. First of all, I want to just point out that a line of best fit was drawn for us. We will eventually draw our own line. So there's just a few things that I want to point out. We're going to try to evenly space. So we definitely want to make sure that our line is following the trend. It's following the slope of the points, the data points that we see, which this one is. I noticed that we're going to try to, like, if you look at these 2 points right here, they're both about the same distance away from either side of the line. And that's what we want to try to do. We just want to try to get things that are same with these two. We want to and these two are as well. We want to try to get points that are equidistant on both sides. So we're trying to kind of average it out. So that would be a line of best fit. So now it says to write an equation for the line of best fit. Well, we know if we want an equation of a line, we need 2 points. So I'm going to start out by writing 2 points. Okay. But we need these 2 points to actually be on that line. So I'm going to just say right now, I would not choose this point because it is not on the line. I would not choose this point because it is not on the line. Actually, most of the points I would not choose because they're not on the line. Okay. That doesn't mean we can't pick a data point, but it has to be on the line. So I'm actually going to pick this point right here because it looks like a pretty nice point. It's not quite up to 75, but it's pretty close. So I would label that point as 1574. Okay, and then I'm going to find another one that is on the line, and I'm going to pick this one right here. And that one would be 18. And again, it's not quite up to 85, so I'm going to say it's up at 84. Okay, so those are the 2 points that I pick. It doesn't matter which points you pick as long as they're on the line. All right, so now we know from here we're going to find that slope. So I'm going to circle my y's. I'm going to go, I think I'll go right to the left this time. So I will do 84 minus 74 for my y's, and I will do 18 minus 15 for my x's. Sorry, I think I had my board slanted. Right, slanted this morning. All right, 84 minus 74 is 10. 18 minus 15 is 3. Notice I get a fraction that does not work out nice. We could leave it as that, or I'm just going to write it as a decimal to 2 places. So 10 divided by 3, you need to put the 10 in your calculator first, will give me 3.33. So that's my slope. And then please remember from here, we're going to be writing y minus y1 equals mx minus x sub 1. And then we need to pick a point. I'm going to pick this point right here. So this is my x, and this is my y, and we've already established that that's my m. So y minus the y, and if you pick the other point, you're going to get the same answer, so no biggie. 3.33 and then x minus my x, which would be 15. All right, so now from here, we know we want to get rid of the parentheses by distributing, or you could draw your area model. Y minus 74 equals 3.33x minus 3.33 times 15 was 49.95. If you wanted to round that to 50, you could. Alrighty, then from here, we know to get y by itself, I'm just going to add 74 to both sides. So I will get y equals 3.33x. Negative 49.95 plus 74 is going to be positive 24.05. So that would be my equation of the line of best fit. So I'm going to write y equals 33.33x plus 24.05. All right. Now from here, the reason that we like to write equations is so that we can make predictions. So this says to use your equation to predict what the temperature would be if a cricket chirped 25 chirps per second. So 25 chirps per second. If I look up here, chirps per second is on my x-axis. So that is an x value. So when I go into my equation of my line of best fit, I'm going to put that in as an x value. So I'm going to have y equals 3.33 times the x value plus 24.05. And if I go ahead and find out what that answer is, I will get 107.3. And I noticed I'm labeled in degrees Fahrenheit, so it'll be degrees Fahrenheit. So that's what I could expect the temperature to be if the cricket chirped 25 chirps per second. Okay, so now we're going to try another one. If you feel comfortable, you may feel free to pause this video and try it on your own and come back and see how you do. If you feel like, ooh, that was just too much information and I just like to watch going through, that is fine as well. When you do get to the pause point and it does ask a question, you can just enter in, just put, I'm watching. All right, and you can put that, and then I'll know that you're just going to watch it instead of trying to figure it out on your own. Okie doke. So the first thing that we are going to do is look at what this is talking about. We've got hours watching TV, and then we've got test score. So you can see as the number of hours someone is watching TV increases, their test score seems to go down. All right, and the correlation is positive or negative. I would definitely say negative as the x value is going up, the y value is going down. And the correlation is weak, strong, or none. I would say most of these data points, again, are pretty close to the line of best fit, so I will call it a strong correlation. And then once again, the line has been drawn for us. And remember, we will get to do that on our own when we see each other in class. And we will notice that, again, when you draw that line of best fit, it has to follow the trend. So notice it's following the slope of the points that were already there. And we're going to try to get points that are equidistant. So all the points, we're going to try to get them pretty close. Notice this time a few of the points go right through, and that's fine as well. So next thing that we want to do is write an equation for the line of best fit. If you did it on your own, you might have picked two different points, but if not, just pick right with me. I am going to pick actually a data point that falls right in the middle. So I'm going to pick that one right there, which would be 3 and then up 70. So 370 would be the first one that I'm going to pick. And then I'm going to pick another one. I'm going to pick this one right here. It seems to be like, whoop, pretty nice one. Notice I'm not picking the data point above it. I'm putting a dot right below it. So that would be 4. And I think it's a little bit above the 60. So I'm going to call it 461 this time. All right. So then from here, I'm ready to find that slope. And again, I'm drawing crooked. Okay. So my circle my y's because I just like doing that. I'm going to go left to right this time. So I'm going to do 70 minus 61. And then in the denominator, I will have 3 minus 4. 70 minus 61 is 9. 3 minus 4 is negative 1. 9 divided by negative 1 is negative 9. The biggest thing is you want to make sure you're having a negative slope because the line is decreasing. So from here, I'm going to pick that first point, write my equation, and then I've got my x and I've got my y. And let's see here, I'm going to have y minus my y is 70. My slope is negative 9. X minus my x value is 3. And then from here, I am going to be distributing. So y minus 70 equals negative 9x. Negative 9 times negative 3 will be positive 27. And then from here, I will add 70 to both sides. So I will get y equals negative 9x plus 97. And I will write it over here. Y equals negative 9x plus 97. If you were trying this on your own, you would not necessarily get the exact same answer as me, but you should get something pretty close. All right, so the whole purpose of finding an equation of a line of best fit is to try to make a prediction, which we're going to do now. So this number 4 says to use your equation to predict your test score if someone watches 10 hours of TV. So let's look at this 10 hours of TV. Notice that hours watching TV is on the x-axis, so that is an x value. So I'm going to put it in for x in my line of best fit. So y equals negative 9 times 10 plus 97, and when you figure that out, it will be 7. So we could predict a test score of 7. Hopefully that would be higher because you're at least listening in class. So that would be what it was. So hopefully now you are familiar with finding an equation of a line of best fit.